All right. Let's talk about period 2 Bohr models. So, period 2 is literally row 2 on the periodic table. So we start with lithium. Lithium has a mass number of 7 for the most common isotope. So 3 protons, 4 neutrons, and I have 3 electrons. 2 electrons in the first, 1 electron in the second. There's lithium. Next one, beryllium, mass number 9. So, 4 protons, 5 neutrons in my nucleus, 2 electrons in the first, 2 electrons in the second. Next one, boron, mass number 11. So, 5 protons and 6 neutrons to give me a mass number of 11. 2 electrons in the first, 3 electrons in the second. After boron, carbon. 12 is the mass number, so 6 protons, 6 neutrons. 2 electrons in the first. How many in the second? 4 electrons in the second. Nitrogen 14. So, 7 protons, 7 neutrons. 2 electrons in the first. Oops. Can't write. And 5 electrons in the second. Oxygen. Oxygen 16 is 8 protons, 8 neutrons. There's my mass number 16. 2 electrons, and then 6 electrons. Fluorine. My mass number is what? Most common isotope is fluorine 19. So, 9 protons, 10 neutrons. Oops, messed up my color scheme. 9 protons, 10 neutrons, 2 in the first. How many in the second?
7.
And last, neon. What's my mass number?
20.
So, 10 protons, 10 neutrons, 2 electrons in the first, 8 electrons in the second. Do you notice any patterns here?
Yep.
What pattern do you notice? They get bigger. Please define. What's getting bigger? Well, take a look first at the amount of protons. What's happening to the protons as we go across the period?
Goes up by 1.
Increases by 1. What about the electrons?
Goes up by 1.
Yeah, electrons, same thing. So if you look at oxygen, fluorine, and neon, 6, 7, 8. I increased by 1. Where am I adding all my electrons to? The second energy level. So every electron I add, I'm adding to the second energy level. Hey, what period am I in again? The second. Think that's a coincidence?
No.
Probably not. Okay, so there's your Bohr models for period 2. Now, jump back over to our lesson on Lewis dot structures. Did anybody define valence electrons yet? Valence electrons are electrons in the outermost energy level. Valence electrons are electrons in the outermost energy level. So take a look at our Bohr models again. For lithium, how many valence electrons do I have? 1. For beryllium, how many valence electrons do I have? 2. What about for boron? 3. What about for carbon? 4. Nitrogen? Oxygen? 6. Then 7. Then 8. So, we know for lithium, I have 1 valence electron. Now, when I'm drawing the Lewis dot structure, I'm going to write the symbol, and I'm going to represent that 1 electron with what? 1 single dot. Boom. There's my Lewis dot structure. Do you see any paired up electrons? What does paired mean? 2. So do you see any groups of 2? No. So you have 0 paired electrons. How many unpaired electrons do you have? In this case, you have 1. So let's take a look at the next one. Beryllium. Be. Here is your rule. You have to go around 1 time before you can double up. So here I have 2 valence electrons. How many paired electrons do I have? 0. How many unpaired do I have? 2. Let's jump down to oxygen. Here, oxygen has 6 valence electrons. So, I'll redraw this so you guys can see it. There's my O. 1, 2, 3, 4. Go around each side once, and now I double up. Here's my 5th electron. There's my 6th electron. That gives me 2 paired electrons and 2 unpaired electrons. That's where I get the 2 paired and 2 unpaired. So I want you to finish up this table for the rest of period 2.